In this lesson, we're going to talk about the relationships of angles between parallel lines and a transversal and the angles of a triangle, interior and exterior angles. So the first part of this lesson is definitions, theorems, and properties. So I'm not going to read through each of these, so you can pause the video and copy these in your notes. So we have vertical angles, linear pair, complementary angles, and supplementary angles. And a lot of these terms are going to be just a refresher for you. We have all the definitions and theorems of perpendicular lines. Now let's get into a lot of the terms we're going to be discussing for this lesson, and it's when we have a pair of parallel lines, and then we have a transversal. As you can see, a transversal is just a line that intersects two other lines. They don't necessarily have to be parallel in this example to the left, but the ones we're going to talk about, it is going to have a pair of parallel lines with a transversal, which creates several important angle relationships. With both of these diagrams, the outside of the parallel lines is the exterior part, and between the parallel lines, or doesn't even have to be parallel in this case, is called the interior. So let's talk about a few of the angle relationships when the lines are parallel. And if you didn't notice on one of the screens, this is an indication. This is the notation to indicate these are called feathers, and that indicates these are parallel. So when we have parallel lines and then we have our transversal, you can see a lot of angles are created, and they have special names because of their location. So we have alternate interior. Again, this is inside the two lines, the interior and alternate on the opposite side of each other. So angle 4 and 5 are congruent, and angle 3 and 6 are congruent. I will just say for a lot of these theorems, they have a theorem converse. So if I tell you M and N are parallel, then you can know that 3 and 6 are alternate interior because M and N are parallel lines, and you know 3 and 6 are alternate interior, which means they're congruent. On the flip side of that, if I say angle 3 and 6 are alternate interior, therefore they're congruent, then I can conclude that M and N are parallel lines. So the word converse just means kind of the flip side of the regular theorem. And it goes on through all of these. Alternate exterior, they're on the outside of the parallel lines, and the angles that we're referring to are on the opposite side of the transversal. So 1 and 8 are both the same measurement, as well as 2 and 7. So each of those pairs are called alternate exterior. And again, we have the theorem converse. Corresponding angles, it just means the angles are in like the same location. So if I were to take this part of the diagram and lie it on top of this part of the diagram, the angles that line up are corresponding. They're in the same location, and therefore they are congruent. And again, the converse theorem tells us if angle 1 and angle 5 are corresponding, therefore they're congruent, then I can conclude that M is parallel to N. Same side interior angle. So we're getting into a little, not congruency, but we're getting into supplementary. And so, and with all these diagrams, there's really two relationships going on. Either the two angles are congruent or they are supplementary, meaning they add up to 180 degrees. So same side, okay, so that means they're on the same side of the transversal, and they are not congruent. 3 is not congruent to 5, but they are supplementary. So angle 3 and angle 5, they add up to 180, as well as 4 and 6. Vertical angles, they are just angles that are opposite of each other, across from each other. They do not share a ray. They do share a vertex, but they do not share a ray. And so we can say those are congruent. And they don't necessarily have to be in this particular diagram. I could just draw, two lines right here, and I could say this angle is vertical to this angle, therefore they are congruent. And now let's talk about a linear pair. A linear pair is just, they're adjacent from each other, and then they do add up to 180. So like 1 and 2. So this 1 and angle 2, they are a linear pair. Linear means line, and we know a line, measures 180 degrees. So angle 1 and 2 are linear. We can say 2 and 4 are linear, 4 and 3 are linear, 3 and 1. So there's lots of linear pairs in this diagram. And again, their relationship is they equal 180 because they are supplementary. And here's a couple more theorems we're not necessarily going to use in our practice problems for this lesson. Okay, so let's get to these problems.